Oh my gosh, this has been good. I've been learning a lot. Kubernetes has been a weak point for me.
I'm glad.
So it's been good to get some of the really fixed content that we've been talking about going through and really diving into and learning more about pods and how to scale and how to set up the services. It's really it's been good for me to see.
Awesome. Any questions we want to take, Jeff? Before
Let me
we
see if there's a question here about Kubernetes being used for on-prem deployments, on premises.
Yes, and I thought there was an answer to that on the chat.
Yeah, there was a good answer. I wasn't sure if you wanted to chime in there as well.
It could be, yes, absolutely. I mean, Kubernetes can be definitely used on-prem, and I've myself helped customers deploy a few of those workloads. So absolutely yes to that.
Yeah, it's just a question of how much do you want to manage.
Correct. Correct.
Sure, you could do it yourself, but you're doing it yourself versus let Azure or another cloud service manage it, and they manage it. They handle all the deployments, all the good things. So,
right.
Yeah.
Exactly. Cool. So, I'm going to turn my webcam off to preserve some bandwidth here and then jump right back into Service Mesh.
Okay. Yep. Go ahead and share your screen. I see it shared there. Go ahead and pivot away from when you're ready.
Fantastic. Okay. So thank you, everyone. I know it's probably pretty late on East Coast, and for folks who probably are, watching this across the world. So we're making progress, and I think we are towards the end here. So I want to talk a little bit next about Service Mesh, and that's something I mentioned in the morning as well, and Rob alluded to that as well. So let's talk a little bit of Service Mesh. All right, so let's kind of go back to one of Rob's slides. One of my favorite slides is where he showed, the mobile device, there's a web browser, there's an API gateway, and there are these bunch of these services on the right-hand side. And then the slide basically talks about cross-cutting concerns, right? The slide talks about, hey, how do you do authentication with the microservices design in mind, or with microservices style architecture, right? How do you do logging? How do you do deployments and so on and so forth, right? And obviously some of the options there were, hey, let's invest in an API management tool. So Azure API management comes to mind. It does pretty much everything. It does security using XAML, JWT. It does policies, front-end policies, back-end policies, and so on and so forth. Or we could use some other, tools of choice for the gateway, et cetera, et cetera. But regardless, I think we are still kind of building, and we may be able to take some of the cross-cutting concerns out, but we are still building resiliency into our code. We are building retries into our code. We are building exponential backoffs into our code. In some places, we are also trying to do API economy into our inside of our code, traffic shifting, et cetera, right? So what we want to do next is obviously understand how, as we kind of build these microservices, we get away from, kind of repeating ourselves with those cross-cutting concerns in different places. And also, even if we use a tool like Gateway or something, we kind of, abstract that out into a highly configurable, plugin model. And, we may choose to call it a gateway. We may choose to call it a service mesh, but the point is, let's kind of get away from, duplicating that kind of code everywhere else and kind of have a consistent story around that. So with that in mind, let's talk a little bit about service mesh. So, if you think about application development deployment over the last few, obviously, years or more than that, it's all been about, dump pipes and smarter apps, right? Where basically all the logic and all the intelligence is built into the API endpoint, and my API is bloated with all different things. I've got authentication libraries going on. I've got logging libraries going on. I feel pretty cool about it. But now with microservices, you're not building 2-3 REST endpoints. You're building hundreds and possibly thousands of these, right? So those intelligent APIs obviously they are kind of working over time, right? So with service mesh technology, the idea is let's make those dump pipes slightly smarter, right? And let's basically take out as much cross-cutting code from those endpoints, right? And that's where we get into the service mesh technology. Now, broadly speaking, if I can go forward here, this is my favorite slide to basically talk through service mesh for folks, who are basically get into this space. So in terms of the orchestrate, right? Maybe orchestration is also kind of new for some of the folks today, but it's it's understandable. Kubernetes and some others before Kubernetes, like Docker has an orchestrator, and there are a few others: Swarm, Mesos, DCOS. So they all kind of provide you these core capabilities. They provide you cluster management, they provide you scheduling, they provide you service discovery, and I'm not going to read through all of them, but we talked through those in the previous slides, and they kind of align pretty nicely with Rob's microservices architecture, right? Because we need all of those to run our microservices effectively. But how about some of those missing service level needs, right? That's where we talk a little bit about API gateway, how that gets plugged in. Circuit breaking, right? We hear a lot these days about traffic routing and canary deployments, right? So I have kind of a version of application deployed. I want to deploy a different version of the application, and maybe I want to coexist them for a period of time, see how it's doing, and at some point I kind of flip the switch and let all that traffic go to that other endpoint, right? Timeouts, retries, per request routing, right? So you basically route requests based on, for example, URL paths, based on request headers, based on cookies, and so on and so forth, right? So how do you effectively do per request routing? Transport encryption, that's a big one, right? I mean, I'll talk about some of the application gateway front door stuff. There were some questions on that, and I have a couple of slides towards the end where we talk architecture, right? Solution architecture with respect to AKS, with respect to Kubernetes, with respect to Azure, with respect to Microsoft, story on that. And there's another slide about, hey, how do you choose the right technology for the right application, right? Or the right platform in this case. When do you use AKS? So I mentioned that at the onset. So we'll talk about those. I'll keep some time so that we can do like effective Q&A on those if needed. But before that, let's talk about transport encryption without having access to tools like that, right? And in this case, it will be the service mesh, which now will be responsible for kind of doing some of the TLS stuff, right? So request comes HTTP to the API gateway. Typically, API gateway then has the ability to do SSL offload, and then you can choose to bypass, or you can choose to persist, HTTPS across the board. But that is again like an ordeal. A lot of customers I work with, they're doing a lot of AKS development or deployment, right, for .NET Core applications, and there's few ones customers I've been working recently with. It's nice when we do it locally, and then they want to put it on AKS, and then they have other backing services which require an OAuth token, and OAuth token needs the HTTPS, and now they're stuck. Hey, how do I do HTTPS on AKS, right? Then, obviously you can use Cert Manager, Let's Encrypt to set up HTTPS straightforward. But now I have a bunch of these services. I may have to do it for all of them. So that's where, these missing service level needs, or some of these needs are nicely met using a service mesh, right? That's what I'll show you as well later on. Quota management, policy, access control. Quota management would be around API economy, right? Who gets to call a particular API, like let's say catalog API. How many times can a client call it, and how does that look like? And at what point do I kind of limit the calls? Which would be call limiting, which would be obviously a policy I have to apply. Access control. So obviously, as you start building microservices, you kind of all of a sudden realize that you have potential to do so many different things, right? Because the microservices architecture kind of opens up into a plethora of opportunities to do these things, right? A lot more easily, because you have these decoupled services, and they can pretty much move around easily. Now, with that being said, you obviously would want to do them in an automated fashion, and that's what I will go next. So some of the service mesh approaches, right? I mean, or the tools out there, there's obviously HashiCorp's console, there's Google's Istio. I don't believe that's been donated to CNCF yet. There's Linkerd. So on our AKS platform, we support all of these, right? So if you go to our AKS documentation today, you'll find that we have support for all three of these, and there's pretty good documentation. You can go through that, and you can run these on these different service meshes, and get like a fairly consistent experience, except that one mesh may be slightly more complicated and feature richer than the other ones, but the basic ones in terms of load balancing, in terms of transport encryption, you get all of that out of the box with most of these with minimal effort. And I'm going to kind of showcase, demo the music store app we have using both, or in this case, Linkerd and Istio, show you both of those examples and show you how that all works, and kind of answer some of the questions I think we had in the morning. We talked about App Insight, a great, obviously, offering, and then there are other open source tools out there like Prometheus, show you that integration. There's obviously Jaeger integration, show you some of those integrations as well. Now, in addition to that, in terms of what we are doing as Microsoft, we are building what we are calling like a facade, a public facade service mesh interface, SMI, for Kubernetes, in partnership with, if you notice, a few mesh folks are already here. There's Linkerd, there's HashiCorp, which has console. So we're working closely with them, and the idea is, hey, it's like, the comparison would be .NET Standard. When would you use .NET Standard? You would use .NET Standard if you have, obviously, consumers or clients which are WPF, and clients which are probably ASP.NET Core, right? So you build .NET Standard, then that way your code is portable and can be obviously exposed through Core and through other runtimes, right? So similar approach here is, build this facade API and then say, hey, a service mesh, first-class service mesh for the industry should have these different capabilities. It should have canary deployment capability. It should have transport encryption, blah, 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 blah. And then on the other side, whatever you end up choosing as your actual mesh kind of fits in nicely because that's kind of what we'll mandate, and they'll make sure that they have those, right? So that's kind of work which is going on right now. And this work has started, I would think, probably about 9 months back. So let me kind of walk you through some cool stuff with this and see if that makes sense to you guys. So let's go back to our deployment. So let's start with Istio first. And in terms of, hey, how is all this orchestrated right from ground up? So, obviously in the interest of time, again, I will tell you kind of high level. So if you do kubectl get namespaces, I have a namespace for Istio. I have a namespace for Linkerd, which means I have already done the installs for those. Again, the documentation is awesome on our side for this. You go ahead and you basically download the Istio binaries, or you want to call them, right, or pods in this case, or manifests, install them on your Kubernetes. So for example, if I do kubectl get pods, namespace Istio system, these are all the different pods running in my Istio namespace. You will find a little bit of overlap because Linkerd also uses Grafana. So I was like, hey, let me try both of these on the same cluster, and so far I haven't seen any issues with that. So if I do Linkerd, and notice here Linkerd has it. So these are all control plane, right? So quickly, before I actually show you a demo, I will show you an architecture which is kind of consistent. And I thought I had that here. Give me 1 second. Let me pull up just one architecture diagram for us. So just quickly, let's kind of go through this. This is Istio specific, but kind of a consistent model, right? So service to service communication, how does that happen in service mesh? And what is a service mesh? It's basically a configurable, you can call it an infrastructure layer, right? Which basically takes away all that, I think I may have a definition here quickly. A configurable infrastructure layer for a microservices application. It basically moves out all of those cross-cutting concerns out of your application layer, and then it moves those down to the infrastructure layer, and it's responsible for blah, 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 right? Service discovery, traffic management, security policy, we'll see that in a bit. And typically, what these service meshes have, they have obviously a control plane and they have a data plane. So in this case, I'll be showing Linkerd as well in a second, but this is like Istio's architecture. So here's the data plane where the service is shipped, when you deploy this, gets shipped with a proxy, right? So I have an Envoy proxy here, obviously injected into the service. So just, imagine this was our API gateway, service A, and imagine our service B was our catalog service. And when we basically set these services up, we're going to inject them with the Envoy proxy. And now Envoy proxy is running as a container with that service, which is API gateway here, which is the catalog service here. And any communication to those services actually happens obviously through that proxy, right? So there's proxy to the service inside of that pod, loop back, right? Back to the client, right? Or in this case, back to the other service. HTTP2 support, gRPC obviously runs on top of HTTP. 2, TCP, you can do MTLS, non-MTLS, we'll talk about that. And then most of those platforms there, like, Console, Linkerd, or Istio, they provide you this control plane, which obviously has those has those components like Pilot, and in this case, there's Pilot, which provides configuration to the proxy. There is Citadel, which does MTLS stuff for you. There is obviously a mixer which does policy checks, telemetry, as I was saying, limiting, how many calls you can make, and so on and so forth. But this is kind of the basic premise here, right? And I already talked about our service mesh interface, which is what we use, or we are actually building right now. Again, not obviously a new concept, because we do something like this today, right? We have Nginx for ingress. Some people use, I heard or I saw Trafiq being mentioned in the call. There's HA proxy, so there are quite a few proxies out there. So let's kind of look at a little bit of demo here to kind of make it all real. So Linkerd pods here running in the namespace. This is the Istio pods running. So let's kind of first start with the Istio example. So let's do CLS, dir. Let's jump into that, right? And I'm going to show you the config here. So what we're going to do first is we are going to, let's go back here. We're going to create a namespace for Music Store. Just a separate namespace so that we don't kind of, overlap. So simple Kubernetes command, create a namespace. And then obviously different meshes do it differently. Now if it's Linkerd, you just run an inject command. Now in the case of Istio, I can basically label the namespace. If you notice here, I can just move out. Label the namespace with Istio injection is enabled. So what that does for me is, anytime I deploy a pod within that namespace, Music Store namespace would be all these microservices, then it's going to automatically inject the proxy for us. So next thing I am going to do is I'm going to basically deploy our Music Store application. And here's the Music Store application deployment YAML, very much consistent with what you saw when we ran it standalone. Before that, I might just kind of do this. I don't want to kind of get into resource contention. Let's delete our earlier application, which was a deployment v2. Give it a second here. Come on. UI has a load balancer, so sometimes it may take time to bring that load balancer down or scale it down. Let's just, yeah, I think it's done. I think so. If I do get pods, there's still ngdev, that's fine. Okay, so let me go back to this guy. And let's do, we already injected, so the next thing for us is to deploy this app, which is going to be my steps. Where is this? Right here. And this is a simple deployment file. It's basically going to take all those different services and deploy them just like before. Now, again, in the interest of time, let me explain you a couple more things we would need to do to basically now start leveraging some of these service mesh capabilities. The first thing is now like an ingress, right? So in this case, what gets exposed through Istio is obviously a gateway. So we create, and these are all CRDs, right? Custom resource definitions built on top of, the platform, the Kubernetes platform. So we create a gateway, or we use the default ingress gateway. The port is whatever. In this case, it's HTTP on 80. And then there's a concept of a virtual service. Virtual service basically is used to do routing. So once we have exposed the gateway, it's listening on that gateway. If the request comes into the gateway, it doesn't get denied, it's accepted, goes all the way into the virtual service, and that's where you kind of do a little bit of per request routing, right? So we are saying in this case, hey, the request comes without any prefix, route it to our music store application, right? So let's go ahead and do the next step here, which is to deploy the gateway, which I would have to deploy. Let's see if this works. I'll have to go to bash. Error. Okay, so I might as well do this. Okay, this is what it's called. So let me just go back here. Let's do okay. Okay, let's do that. And let's just pick the right file here. The file name is rename, and I'll just kind of bring this all together in terms of the story here. Just let me just run through this file first. And the namespace is music store. Okay, so we did that. This should run. All right, so now I can do kubectl, get gateway. A gateway would be created for me. There would be a virtual service also created for me. So all that gets taken care of through that configuration in the music store namespace. And then if I now go and get the endpoint, which would be kubectl get service endpoint for the ingress. So let's go get that. Now we are saying get the IP address, which basically is the IP address of my ingress, in this case the gateway, right, which is exposed by Istio. I don't need to open this. Let's keep it here. Now this is the endpoint here. Let's open that up. That should basically open up our music store application. There you go. Blah, 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 right? So that's good. So we got basically that set up. Now there are a few things we can do, right? And obviously, again, in the interest of time here, I mean, we could do canary deployment, right? So right now we have the version 1.0, right? And we could create a version 1.1 for the UI, or, you know, maybe for some backing service we have for this UI, like a catalog or basket. And then we could do, you know, kind of match labels, right? We could say, hey, if someone is coming with the version 1.0 of the service, you know, obviously, then, you know, if someone is coming with this particular label, move them to 1.1 or 1.2. You can do all the cool things with those destination rules. But here I'm just gonna show you. We're gonna do that too, but we also gonna show you like a quick TLS. So right now, if I go back to my sticky notes, and no, not that guy. So if I just show you the current basically communication, because what are we saying? We're saying the cross-cutting concerns are now basically done by the mesh. So TLS is one of those, right? So right now, if you notice, now I'm running obviously this command where we're saying, hey, basically tell me how does the UI talk with the gateway, right? So this is going to be right now without TLS because we haven't enforced those policies, right? So there is, actually it comes back with nothing. It should basically say there's nothing running. I mean, it should say it's not. See, gateway, I guess this is called as API gateway, that's why. Yep, I think that's what our API gateway is called, API gateway. There you go. So obviously we haven't configured the policy yet. So now if I go back to my this step, which is to enforce a policy and then say, hey, there should be strict mutual TLS between these services, right? Then it will basically enforce that. Again, that's one example of how you took one of those service level needs, like in this case TLS auth, or transport encryption and have service mesh do it for you, right? So let's go ahead and run this guy. So this would be, give me 1 second here, trying to point here. So that would be here. Let's go back steps. And that would be the last one here, this guy, and I think that should be fine. Okay, awesome. So that should have done it. And now if I go back to show you the traffic in the services here, we'll notice. Okay, and then in the meantime, let me kind of open up a few things here. So let me just give me a second here. Let me show you. Yes, so if you notice here, Istio mutual, strict, right? So it's not permissive. Permissive is obviously, it's bypassing TLS. Now we said, hey, we want to have strict TLS and it should be mutual TLS, right? Not just one side accepting certs, both sides should accept certs, right? So that's a design of most of these meshes where you don't have to worry about setting all that up. That gets offloaded. In this case, Citadel does it. In case of Linkerd, a component does it. Console, a different component does it. So that's pretty cool to see. Okay, now the next thing I want to show you is quickly the Prometheus here, which we can just quickly run. So that's obviously your monitoring, open source monitoring, where you can have Prometheus counters, just like App Insight counters. You can have Prometheus counters, and these counters then obviously get exposed through the Prometheus server, which gets installed out of the box when you install a mesh like Istio, and then you can obviously do obviously Grafana dashboarding along those counters. So quickly here, this was what, 8080? Did I do 8080? Let me see. 9090, sorry. So let's do 127. Oh, I don't want that one. I don't want that one too. I want the one which will not disrupt this thing. Running a few things here. Okay, so that's my Prometheus here, and I can see obviously the service mesh is self-serving, so it's obviously the default monitoring all of its own counters, right? But then you can extend that to service counters, right, which you're writing. So that would be Prometheus. Now the other one I like to show before we move to Linkerd is I like this one a lot. There's Jaeger 2. This is kind of a nice tool as well to kind of see the relationship between different services, etc. And by the way, these are all kind of the telemetry tools, right? So obviously the mixer in this case is kind of exposing this on an endpoint, and all these tools are plugged in, right? And they're able to kind of do that. So 20,001, localhost, 20,001. Okay, so this is going to be interesting. If I can remember the, okay, so this, let's give it a shot. I set it up yesterday, but I think I do password 123. I'll keep it simple. Perfect. Okay, save, well, never for now. So you notice all these different applications, and I'm just kind of zooming out a little bit. You can look at all the applications. You can look at workloads per namespace. So if I go to our music store app, here's our music store app. So you look at obviously the status of your applications, and Linkerd also has a nice dashboard, which I'll show you next. It kind of shows you. So the idea here is obviously as you build microservices, it's, as Rob mentioned, the code from Sam Newman. Logging obviously is the first thing you got to do. I mean, you can start building services, and then you'll realize, it's all over the place. You don't know where things are breaking. So if you start with as we say, the cloud first approach, mobile first approach, so the log first approach, right? So that's where you start. You create proper logging infrastructure, and then you start building these services, right? Using that infrastructure, it's easy to debug and understand. And some of these tools, they don't do everything, but they obviously give you good insight. Now there's pass-through, there's some issue, I don't know what it is, but you can see inbound metrics. outbound, etc. So I'll move on. We can come back to this if needed. And then finally, while we are on this part, let's see the Grafana one, and then we'll move to Linkerd. We'll move to Linkerd next. 3000. So let's do localhost. Okay, should be back. So here too, it's going to look for okay. So thought that was a password. Okay, I'll move on to Linkerd because there the dashboard is straightforward. Yeah, I'll show you the dashboard anyway through Linkerd. So let's move on to Linkerd here. That was one of the examples of a mesh here, right? So I want to show you kind of a different mesh which has been installed as well. So let's go ahead and before that delete the namespace so that we don't impede. So just simple as, deleting the whole namespace, all our artifacts go away, starting fresh here. And now let's basically look at how Linkerd does it. I hope I copied where's my cheat sheet here? Yes, I do have it. Perfect. All right. So first thing we'll do, we'll basically go ahead. We are using the same, obviously, application, right? And I'm going to go ahead and use the same application to create my artifacts, right? So the first thing would be, let's go ahead and just should we put in the default namespace? Yeah, it doesn't matter. So let's put the stuff, Linkerd stuff in the default namespace. And I'm basically doing nothing to our deployment file. It stays as is. So I've just called it Linkerd just for ease of use. It's going to deploy all those different artifacts inside the default namespace. So now previously with Istio, we basically labeled the namespace and that allowed us to inject the proxy, right, automatically. In this case, we're going to add one more line. Before that, we're going to make sure. And by the way, if you notice, my services for both Istio and for Linkerd don't have any load balancer. They are just using the default cluster IP because, that's how I want to use them. I want to have the ingress and that load balancing and all that gateway stuff taken care by the mesh in this case, which is like a gateway, right, for most part. And not let kind of each service be a load balancer because that kind of defeats the purpose here, right? So the same thing here, I have all these pods running inside default namespace and I can do service. These services are all running with the internal cluster IP. Why is this having an external IP? Did I not remove load balancer from there? Maybe I... interesting. So where did I run this from? That's fine. It's okay. So next thing I'll do is I will go ahead and do Linkerd dashboard for us. Let's do it. Let's open a bash here. Hopefully it doesn't conflict with anything else. No, I don't think so. Give it a second. I've seen this issue before. Port flag. Let's see if we can listen on any other port, 750. Oh, that's because maybe here's a proxy running here. So let's close that. It's probably not able to do two dashboards at the same time. So let me close that. Let's go back here. Let's do it works. That's fine. Regardless, I'll still apply this, this kubectl, which is to basically inject the proxy for us. So I'll copy that, and that's, yeah, I think I'm something going on here, but that's okay. We'll just do kubectl get pods, and maybe we can try it from here. Okay, that's okay. So if you notice here, there's just one pod running. When we do the linkerd inject, which is this guy here, this guy is, sorry, let's put it in the right namespace. It's default namespace. That. So essentially the same thing gets done, where it basically injects the proxy, and the kind of the traffic flows through that proxy into the services, etc. So one second. You know what the problem is? There's no namespace described. So what do you think will happen? Now let's run that without the namespace attribute. And I'll see if we can go to Grafana through. Yeah, so notice here now that command basically injects that proxy. Now if I do kubectl get pods, I'll get pods. So notice how it's basically, you know, adding that proxy inside each gateway, because now if I do kubectl describe pod API gateway, you'll see a couple of, and it's basically killing the old ones, and it's creating new ones and injecting the proxy. And notice how there'll be two containers. One is the gateway container itself, which is my gateway latest. And then there is obviously the other container, which is a linkerd proxy. And that's the idea there, right? And the dashboard, basically the linkerd dashboard is, you know, like similar to the Kubernetes dashboard, where it will show you services and it will just tell you what's the health, what's the, you know, inbound traffic look like, and so on and so forth. All right. So any questions, Jeff? A few other things to cover here, and I'll give it back. Any questions so far on service mesh?
There was a question here about how you ran a local command for Istio and linkerd.
Oh, how do I? Oh, sure, absolutely. So great question. So how I did that was, so just like, you know, all these CLIs available. So there's a kubectl CLI available. Similarly, there's an Istio CTL. I didn't use that. I guess used a few commands. And there's linkerd available too. So all these are, you know, kind of client libraries available. And then they basically would allow you to then, you know, interface. Was that the question?
Well, the question was, it feels like due to the modular nature of Kubernetes, they should almost be sub-commands of kubectl. kubectl.
True, and that's where it's kind of heading to. If you notice, if you notice when I ran the Istio CDL, when I ran that command, it said that it probably will be deprecated, so you're better off using kubectl. So you're right. So more and more of these features are probably getting consolidated within kubectl for ease of use, so that folks don't have to do 100 different things, right? So for example, let me just kind of, while we are on this topic, if I do kubectl get pods to our linkerd injected pods, so let's go back, and if I do kubectl, I should be able to basically now do port forward. That's not what I wanted to show. Get pods, namespace, linkerd. I don't need linkerd dashboard as such to go to Grafana. I can do that through kubectl as well. So let's see if I can. kubectl port forward. First of all, let me see what port they're running on. Does this one tell me? It's okay. Grafana is typically 3000, so let's do kubectl port forward. we can go describe and see if that is the port it's running, but I'm just guessing it's 3000. I might be wrong. We'll see. Grafana is not in this namespace. Obviously, it is in the namespace. Linker-D. And yeah, there were some questions. I'll use this time to discuss that too. So about claims, right? So, it's interesting where this is all kind of heading, right? So a lot of these meshes are also, they're also building OAuth, token validation inside of these meshes itself, right? So service-to-service token validation. So obviously, one of the design would be, you have an identity server, maybe, deployed as a pod, and then you obviously claim that, claim a token or get a token through that identity server, either through like a kind of identity provider like Azure AD or through an identity server deployed as a pod. You get that claim, you send it to other service. So other services set up with those policies. So those would be like auth. That's basically called as end, if I can remember, end user. User origin, end user origin authentication. So that's built into a lot of these meshes where now the mesh will make sure that claim gets validated in terms of does it have the right key, is it being tampered with, is it not expired, etc. And then as it goes into the app, you can do more kind of sophisticated authorization at that point. So the point is, a lot of that stuff is now getting into these areas, and your application needs to worry, your microservice needs to worry less and less about those things. I thought I'll just talk about it. Let's see if it does open Grafana on the Linkerd side. That's okay. That's okay. I'll just move on here. Let me just do one more thing quickly, if I can. Just make sure I'm in the right. Does not have that. Yes, because I forgot to specify pod. Okay, so let's see if I get a port here. 4.1. This is the Linkerd proxy. Yeah, port 3000 is right. So that's fine. I will move on right now from this. So what I want to do next is let me see if there's anything left here from this piece, which I may have not covered. So I talked a little bit about mesh and what's the basic value proposition. Just to kind of close on that, the idea again is this, right? Basically to make sure that we are kind of addressing the layer 7 things. That's where your mesh kind of comes into the picture and kind of complements the API gateway, some of the things which Rob talked about with respect to communication. I didn't show retries and stuff, but you can absolutely do that with these mesh type products where you can give that as configuration. API economy can be given as configuration, and what you can do, that's probably far-fetched for now, or maybe not for all the organizations, where the PM itself, the product manager probably can drive that configuration, through the DevOps, by engineers, etc. But hey, I know exactly who needs to make how many calls. Now, that information is not baked into the code anymore. It's basically outside the code, right? Okay, so that's kind of some of the mesh stuff we talked. Let's kind of move on to a couple of things I want to discuss, and in the time we have, we'll obviously give it back. So one thing was obviously, how does a reference architecture for something like what we discussed today look like when you think about deploying all this into Kubernetes environment, right? So this is just one implementation, or you can think of this as one reference architecture. I'll just take, maybe 1 second, Jeff. I'll take 5 minutes, and then we can talk about other stuff. So here is obviously, if you notice, there is these are backend services, and you can think of these as catalog and ordering and payment and so on and so forth. And you have some kind of a front end ingress. In this case, it happens to be Nginx. You can absolutely use some other kind of ingress. I showed mesh. It could be Rob mentioned the application gateway in one of his examples, right? In this case, it's using ingress and powered by Azure Load Balancer. And then you have obviously the, if it's an AKS, the AKS powered RBAC through Azure Active Directory. There's monitoring, there's Azure Key Vault, or Azure Managed Identity to kind of do some of the identity stuff. And then you have obviously your data, which as your external data sources, right? So, and then you have all this kind of driven through a pipeline, which is CI/CD. In this case, using Helm. You can use, Ansible. You can use Terraform, tool of your choice. And obviously there's container registry involved here. So that would be kind of basic architecture. You have AKS cluster set up with kind of trusted subsystem services. Stuff you want to expose outside goes through some kind of an ingress. Nginx, HA proxy, Envoy, or mesh-like implementation. Then, as I said, all the way to the client apps, and then the deployment would be one story. So that's one piece which comes up all the time. The other thing which gets asked is, hey, tell me a little bit about when to use what, right? I think this is probably a more pertinent question for you guys, still in the call. When do I use what, right? So if you notice here, we have obviously a lift and shift candidate, right? Or it could be a cloud optimized, or it could be, if you take it to the end, it would be cloud native, right? So, if you're doing lift and shift, and you cannot containerize it at the moment, then I think this was a question which came up. Then, if it's an ASP.NET web app, API, Node.js, you can put in app services. If it needs full-fledged orchestration, it's still lift and shift. It needs full orchestration, then you can consider AKS. And if it doesn't need full orchestration, and this was something which was mentioned in the chat too, if it's already using app services, then you can use app services with containers. And if not, then you can, kind of rely on container instances. And we'll obviously share these links with you guys as well. And then, if it is definitely cloud optimized, if it's not an HPC workload, then, if it's HPC, then you may consider Azure Batch. And if it's not, then if it's a microservices architecture, Rob mentioned event-driven workloads, short-lived processes, which we talked about, these pods, which can come and go. If it needs advanced orchestration, then you obviously consider AKS. And now AKS also supports Win servers, so you can do AKS with Win servers as well as Service Fabric, which already supports Win servers. And if it if it's an event-driven with short-lived processes, here that meant more like serverless, then you can consider Azure Functions. And if not, but still doesn't need any full-fledged orchestration, you can consider container instances. So you have quite a few choices here on Azure. App services, AKS, ACI. App services with or without containers to kind of obviously power your workloads. So with that, Jeff, any questions on mesh or anything I've discussed? Let's kind of keep maybe the remaining time for some of the stuff Rob wants to present, and any Q&A from me.
No, the Q&A looks clear right now.
Awesome.
I think I'm just going to scroll back a little here. Yeah, I think we're good. All right.
Fantastic. Cool. Then do we want to maybe then wrap up with some questions or?
I think what we should do is we still have to talk about distributed data.
Sure.
Let's take a brief break, and we can get Rob queued up to finish the day talking a little bit about distributed data and CQRS.
Fantastic.
Perfect.
Okay.
Let's do that.
Thank you.
Take about maybe 5 minutes or
Yeah, let's take about 5 minutes. Friends that are out there watching, grab a beverage, take a bio break, grab a little munchie, come on back, and we'll pick up and finish off talking about distributed data. All right?
Perfect.
Awesome.
Perfect.
Thank you.
Awesome.
We'll see you in 5.